Hello, we're back and better than ever, ready to finish up section 7 of chapter 1. I'm going to start off with an example asking the following question. Where does the line y equal 2x plus 5 intersect the parabola y equal 8 minus x squared? Where do they cross? To give you an idea, here's a y-axis, here's an x-axis, and we're trying to figure out where in general this parabola is met by a line. And this parabola and this line don't necessarily pertain to this particular function, but we're trying to find the ordered pairs at which they cross. There might be one ordered pair, there might be two ordered pairs, there might be no ordered pairs. I want to show you this on the calculator first. So I'm going to add a new video. And I'm going to, I believe it's recording right now. If I can find my calculator, there it is. Okay, go to the y equals menu. And now notice I've already typed in my line in y1 and my parabola in y2. And I'm going to hit the graph button. And you can see there's your line and there's your parabola. And they actually meet 2 times. Now if you go second calc above the trace button, option 5 says intersect. Hit enter. Now, kind of move down towards one of the intersection points and just hit enter, enter, enter. And boom, you can see that one of the intersections is -3, -1. Do it again. Second calc, intersect is number 5. And kind of move up closer to the other intersection point. And hit enter, enter, enter. And boom, you can see that that intersection point is 1, 7. So we just did it on the calculator. Now I want to do it by hand. Alright, well, I'm going to show you a little trick here. Y up here is equal to 2x plus 5. Let's call that junk. Because that's what it is to you anyway, right, sometimes. And y equal 8 minus x squared. Let's call that stuff. Well, if y equals junk and y equals stuff, then we can say that junk equals stuff because they're both equal to y. So we can use substitution. We have y equal 2x plus 5 as well as y equals 8 minus x squared. We'll set those equal. So 2x plus 5 is equal to 8 minus x squared. Now you have a quadratic equation that you can solve hopefully by factoring. Get it set to 0. So pick up x squared and bring it over here so it's positive. That makes life easier. 2x is here. Subtract the 8 from the 5. Now that's equal to 0. Hopefully he factors, and guess what? He certainly does. So x could, let's see, that should be -1, I believe. So x could be -3 or x could be 1. Now we're not actually finding zeros. We're finding intersection points in this system of equations. One of them is a line, the other is a parabola. So you have the x values, I'll go ahead and get them started over here, at which this system intersects. Now you need the y values. So you literally just take these and plug them in, either to this x value here or to this x value here. I think the line would be easier. What about you? So let's plug in, pick the -3 up, and just put it right there. So that'd be y equals 2 times -3 plus 5. Well, that's just -1. There you go. There's an x and a y. That's where the parabola and the line intersect. At least one of the points anyway. Pick up the 1, do the same thing. Put it in for x. So you'd have y equals 2 times 1 plus 5. Well, that's 7. And you know what? Those two ordered pairs match up with the graph that we did on the calculator earlier. Pretty cool. We did it graphically and we did it algebraically. Substitution's a powerful thing. Okay, example 6. And this is a tricky one. This is one where you really got to think. We're looking for an equation of a quadratic function, so a parabola, that has a minimum value of -1, -6. Now let's think about that. If that's the minimum value, that means that's the vertex, doesn't it? Ask yourself if you just heard what I said. If that's the minimum value, that's the vertex. Which, by the way, in standard vertex form, means we have H and K. That's good news. And it passes through another point, -3, -4. Well, that's going to come in handy too. Why am I rewriting the point? I don't know. That's silly of me. What I meant to put was x, y. So we have, when it comes down to vertex form, which I'm going to put right here, hopefully you have this memorized. I'm going to make a note here. I have h, k, x, and y. I need, the only thing I need is a. So we're going to use some fancy substitution here. Plug in 4 for y, leave a alone, x is -3, minus h is -1. Notice that that's going to end up becoming plus. Remember how h is kind of funky, it's kind of backwards? And k is -6. Well, now I can solve for a. Let's do it. 4, that would be -3 plus 1, which is -2 squared minus 6. Add 6 to both sides, that's equal to 10. And 2 squared is 4. So a ends up being 5 halves when you reduce. I divided by 4 and I got 5 halves. Sweet. Now when you write your equation, all you need are a, h, and k. That's it. You don't need to put x and y because they vary. But h and k, h and k are constants. So our equation is y equals a, we just found it, 5 halves, times x minus -1 is really +1. Remember, h is a little backwards, minus 6. Now that is in vertex form, or standard vertex form. That satisfies the condition that we asked. We wrote a quadratic function. But now, supposing you went to general form. Well, you would need to expand x plus 1 to x squared plus 2x plus 1 minus 6. All I did was FOIL there. All I did was FOIL. And now I would have to distribute the 5 halves and combine like terms. So I get 5 halves x squared. 5 halves times 2, the 2's cancel, I'm left with 5x. 5 halves times 1 is 5 halves, but I have to subtract that from 6. 2.5, or 5 halves minus 6, is really the same thing as 5 halves minus 6 is really 12 halves with a common denominator. That's -7 halves. And there you go. That I can put f of x, or, oh, actually, you know what I should have put? Up here instead of y, I should have put f of x, because the direction said write a quadratic function. So I need function notation. This bad boy down here is general form. Either one would suffice. I don't care which one you use. Alright, friends, that's really all I got for this section. Nice short video. Work hard. Ask me any questions you got. I'll talk to you later. I'm out.